Hello everyone and welcome to the new Python video. Today I'm going to talk about generator functions and generator expressions. Hopefully by the end of this video you'll know what both of these are and what they are used for in the Python world. So without further ado, let's get down to it. Generator function, simply speaking, is a function that returns an object that can be iterated over, one value at a time. In other words, generators or generator functions are a simple way for creating iterators because they support the iteration protocol out of the box. But we'll get to that in a bit. When it comes to its syntax, generator functions are coded using the def statement, like normal functions, but the key difference is in the statement that we put in the body of a generator, and that is the yield statement. What this yield statement does, it basically suspends or resumes the function, saving its local state. But what is meant by this local state? Basically, by local state we mean here the code location and the local variables that we create in our generator function. Okay, so now that we have it, let's hop into Spider ID and let's take a look at a simple example of a generator function that will get these things more clear. Alright, so as you can see here, we have a very simple generator function on the left side in the script file. So I'm going to copy that, but before we paste it in here and execute this, let's actually pay attention to the fact that we can have, as mentioned, we can have more than one yield statement in our generator function. And what we do here, we basically yield one value at a time. We produce a series of values in our generator function, but it will get clear in a bit. Right, so I'm gonna paste it in here in our interactive console. And actually, let me copy this here, our function name, and when we execute this, we can see that we get back this generator object. So I mentioned that we can create an iterator using generator function, but we get back this generator object here. So let's actually, what we can do now, let's assign this generator object to a variable, and I'm going to call this variable mygen. So up here in the variable explorer, you can see that we have our generator object assigned to mygen variable. All right, now that we have it, I want to mention one more thing. When we talk about the theory, it's extremely important to mention that generator functions, when we create them, they are compiled into an object that out of the box supports the iteration protocol. But what is actually meant by this iteration protocol? Well, it means that we can access, or we have access to, two special methods on our generator object. And these methods are called the iter special method and the next method. And the second next method allow us to advance to the next item in our iterator. Okay, so to check this, actually, to check if we have access to these two methods, let's take a look at attributes and methods that we can access on our object. So I'm going to copy our variable, our generator object, strictly speaking, and I'm going to pass it to dir built-in function. And now we can see that we have this next method and we have this iter method. And this next method, as I said, it allows us to advance to the next item in our iterator. All right, so now that we have it, let's copy this and we can actually call this function on our generator object. So I'm going to say mygen dot, and we are going to call this method. We can do it either this way, and it will fetch the first item or the first value in our generator function, or we can use a more convenient way using this next built-in function that basically under the hood does the same as we do here. So it calls this next method on our generator object. So if we pass our generator to the next built-in function, it should fetch or it will yield the next value in our generator object. And what it does when we do it, this is a manual way of iterating over this object. What it does when it yields this value, it suspends the function and saves and sends this value back to the caller. But while doing this, the local state is retained. And I've mentioned this already. When we save the local state, we save local variables and we save the code location. So when we call this function next time with this generator object, it knows exactly from which point to start this iteration again. So when we call this again, it will know that we should yield this value here. Okay, so let me execute this, and you can see that we get the number 3 back. All right, so but what happens if we run out of values? Well, if we run out of values, the stop iteration exception is raised. So let me do that. And we can see that we get back this stop iteration exception. But, well, you might be wondering, but normally we don't do that in programs in Python. Well, you're right, because in fact, this is handled under the hood by iteration context. Like, for example, in for loops, this is done implicitly by the for loops under the hood. So we don't call this next method manually if we want to iterate over an object, over an iterator. It is done automatically. So one more thing to mention, which is very important, is that generator objects can be exhausted, meaning that they support only one active iteration scan. So if we wanted to iterate over this object again, we cannot, because we've exhausted them. So we have to recreate our generator object, and that's what I'm going to do now. All right, so let me run this piece of code here again, and we have our generator object back to our disposal. And what I'm going to do next is to use our generator object in an iteration context. And by the iteration context, I mean here the for loop, but there can be more. We can use the built-in map function or sorted function or the sum function, things like that. Okay, so let me write for num in mygen. We're gonna simply print num. And what happens here, this next method that I showed you previously is run implicitly on our object. And when we run out of values, this is gracefully handled by for loops. The stop iteration exception is raised gracefully, and the for loop is ended. All right, so we can see that we get back our values. But actually, you might be wondering, why would we use that at all? Well, the thing is that when we use generator functions, they produce a series of values over time. So they do not build the whole result all at once, unlike normal functions. So if we have a huge data set or a huge list to build, we don't have to wait for it to be built at once. We don't have to wait for it to be built at once in memory. So that's the advantage that allows us for memory usage optimization and performance optimization, especially if we have to do with huge data sets. But the key thing in understanding generator objects in general is to know that when we create them, I want to emphasize this, I want to repeat this one more time. When we create them, they are coded into a special object, they are compiled into a special object that supports the iteration protocol. And the next method, and the iter method that I've mentioned already, is meant by this iteration protocol. So we don't have to create it ourselves. That's why we often say that generator functions are a simple way for creating iterators, because we don't have to implement it ourselves. If we were to create our own iterator, we have to implement this next method in our class and the iter method that returns itself. All right, so I hope it makes sense at this point. So let's take a look at one more example. I'm going to clear the screen here, interactive console, and we're gonna try to code a Fibonacci series using a generator function. So I'm going to define our generator function on the left here. So I'm going to say def fib, and we're going to define one parameter, and this is going to be nums, and this will indicate the number of items or the number of numbers, simply speaking, that we want to create in our Fibonacci series. Okay, so now that we have it, let's initiate first two values. And if you don't know what the Fibonacci series is, don't worry, that's not the point. In this video, I will put a link to the wiki page that explains this. But the key thing is the yield statement usage here that we will see in a bit. Okay, so now that we have it, we're going to use this variable placeholder here because we want to loop through using the range built-in function through this nums value here that we will pass as an argument to our fib generator function. Okay, so now that we have it, let's code the logic here for creating a Fibonacci series values. Okay, so this is gonna be xy equals y, comma, x plus y. All right, and what we want to do here, normally, in normal functions, as you know, we return the whole result immediately. What we do here, we yield one value at a time. So in other words, we produce a series of values over time. So the work is split here, and that is the key difference. Okay, so we want to yield the x value. All right, so it looks like we have everything we need. Let's copy this. Oops. Let me do it one more time, and I'm going to run this here. And now I'm going to pass in 100 as an argument to our function, and I'm going to assign, well, let's actually do this without assigning it to a variable for the time being, and you can see that we get back this generator object. All right, so it looks fine. Now we can assign it to myGen, and this myGen is a generator object. So we can use it in any iteration context that supports it. So when we coded this generator function, it was compiled into an object that supports out of the box the iteration protocol. And by the iteration protocol, again, we mean here the next method, the next special method, and the iter method. All right, so now that we have it, let's try to use it in a iteration context, and we're going to, let's pass this to the tuple constructor. So I'm going to say tuple, and we're going to pass in our generator object. And you can see that we get back all our Fibonacci series of values. All right, so you can see that we have 1, 1 here, according to the definition, and the next value basically is the sum of the previous two. So you can see that 1 and 2 gives us 3, and 3 and 5, 8, and so on and so on. All right, so now that we have it, I hope that it makes more sense, but I want to emphasize this one more time, that in case of generator functions, we do not build the whole result all at once. We produce a generator object that can be iterated over, that we can use in any iteration context. All right, so before we go to generator expressions, let's actually, I know it might seem like it's only theory in Python, but let's actually see how it is implemented in the standard library, because many tools have it implemented. So for example, if we import OS module, we can use the walk function, that is basically a recursive function that allows us to walk through the directory tree and what this function does, it basically returns a yields. It basically yields a tuple of the current directory, its subdirectories, and the files in the subdirectories. So it uses the generator under the hood. Okay, so let's see how this is implemented. So I'm going to say, let's call it new gen, and we're going to use this module, and from this module we're going to take this walk function, and I'm going to pass in only one argument here, and this is going to be the path. We're going to pass our root directory. Okay, so now you can see up here in the variable explorer that we get back our generator object. All right, so if we run this, you can see we have our generator object. So as we did previously, we can run or call the next method on our object, or in other words, we can pass this generator object to the next built-in function. Okay, so that's what I'm going to do now, and you will see that we get back a tuple of values. But why would we use that? The thing is that if this function did not implement generator functions, we would have to, or basically would have to make the caller or the client wait for the whole tree to be scanned. So that's the key difference. We do not do all the work up front. This is the difference between normal functions and generator functions. We produce a series of values over time, and this allows us to split the work into slices. I hope it makes sense at this point. Okay, so now that we have it, now that we have generator functions behind us, let's talk about generator expressions. And generator expression syntactically is like a list comprehension that I've already covered on my channel, and I will put a link to the video about list comprehensions. So if you'd like to watch it, feel free. And list comprehensions or generator expressions support if filters and loop nesting like list comprehensions, but the difference is that in case of generator expressions, we use round parentheses. So the difference is in the syntax that we use. All right, so and let's take a look at that. Let's remind ourselves how a list comprehension is created. Okay, so what we do, let's code here a simple list comprehension. So we can say x, get a square for each number for x in range 10. Okay, so oops, I forgot about one parenthesis here. And you can see that we get back a list. So all the work is done up front, and as a result, we get back this list. But in case of generator expression, so we switch square brackets for round parentheses, and we get back a generator object. And this generator object in turns supports the iteration protocol out of the box. So now that we have this generator expression or generator object, we can pass in our object to any function, or in other words, we can use it in any iteration context that allows us to do this. So for example, what we can do here is assign this to, again, to my gen. Let's call it genx, actually. And again, we can pass this to tuple, for example. But as I said, they can be exhausted. So if we run this again, we get none, basically. We get no values because they can be exhausted. They support only one active iteration scan. So we have to rerun the statement here. So to create a new generator object. For example, we can pass it to another built-in function, which is sum, and it will sum all the values that get created using this generator expression. Okay, so I'm going to pass this genexp, and we can see that we get the sum of all these values, squared values, in our generator expression. Okay, I hope it makes sense. You might be wondering again why we would use them. Why we would use them over generator functions, and this is very similar to the way to the trade-off that we have between normal functions that generate or return lists and list comprehensions. So the thing is that we have a trade-off between conciseness and statement power. So if you have a need to code more logic, you would probably use a generator function. But if you have something simple to code, a simple expression, you would probably go for generator expressions. So I hope that this makes sense. As I said, I think the key point is to understand that these objects, when we create them, whether it's a generator function or a generator expression, they are created, they are compiled into an object that supports this iteration protocol. And this in turn allow us to use this in any iteration context. All right, so I hope that this makes sense. If you have any questions or comments, let me know, as always. If you've liked this video, please do not forget to hit the subscribe button. And I want to thank you for your time devoted to this video, and wish you a good day. Thank you and take care.